Today we're going to be talking about one of the advanced sorting algorithms that we're going to encounter in this class. You may recall that we've already encountered, let me get this all straight here. Okay, we had the three elementary sorts. And you should know what those all are. There was exchange sort, which people like to call bubble sort. And there was selection sort. And the other one was called insertion sort. And we said that the reason why these were called the elementary sorts was because in the worst case time complexity, we said that big O of n was equal to n squared. What we're about to do is get a little better than that. So we're going to be looking at the three advanced sorts. And those are what are called quicksort. There's one called heap sort. And there's one called MergeSort. And these are characterized by the fact that big O of n is equal to n log n. And I think you can see that as n gets very large, this is a significant improvement over this one over here. So today's lecture is about MergeSort. And this is a very clever sort, okay? And it is recursion based. And I hope that's not going to frighten too many people. And I think that it's time that we described it. So let us imagine that we have an array that we want to sort. And I'm going to So there is my array, 1, 2, 3, 4, 5, 6, 7, 8. And I'm writing it this way. And the very first thing I'm going to do is I'm going to come over here and I'm going to split it in half. And then what I'm going to do is I'm going to come over here and I'm going to split it in half again. And I'm going to come over here and I'm going to split it in half again. Now at this point, I have an array here, a very small array, 17, and I have an array over here, again, of one element, 23. And the very nice property that I have of arrays of size 1 is they are already sorted. So what I'm going to do now is I'm going to come over here and I'm going to merge them. And at this point, there's nothing much to do, seeing that they are already sorted. But I'll come down here, and what I'll do is I'll find the smaller one of these two, and I'll put it over here. And then I'll find the larger of these two, and I'll put it over here. Okay? Now I'm going to come over here, and I'm going to cut this one in half. And note that this is a sorted array, and this is a sorted array. And now I'm going to come over here, and I'm going to merge them. And in merging them, I want to merge two sorted arrays, and I want to merge them into a sorted array. So I get a 1 over here, and I get a 4 over there. I'm going to come over here on the right side. I cut this in half. I'm going to cut each one of these in half. Keep cutting in half until I get down to arrays of 1, which are sorted. I'm going to merge again. So when I merge these two sorted arrays into one bigger sorted array, I'm going to put the 3 here and the 86 here. And likewise, when I come over here and I merge these together, I get a 5 there and a 92. Okay, so I did merge here once. Well, now notice this is a sorted array, this is a sorted array, this is a sorted array, and this is a sorted array. I'm going to come over here and I'm going to merge these into a sorted array. So I'm going to put a 1 there, and then I would put a 4 here, 17, 23. And I'm going to come over here and I'm going to merge these into a sorted array. So I'm going to get 3, 5, 86, and 92. So that was a merge. And I'm going to do one more merge. I'm going to merge these together. And I think I can fit this in on the bottom of the page here, very sloppily. So I'm going to get first a 1. First of all, let's explain how this is going to work. I'm going to maintain, and we'll see this later in the code, I mean a reference to there and a reference to there, and I see that this one is less than that one, so I'll copy the 1 here, and then I'm going to advance this reference over to here. And now I compare this one and the 3, and I see that the 3 is smaller, and I'll advance this reference now over to here. And I'll compare this one with this one, and I see that the 4 is smaller. This is the merge step, and we'll write the code for this shortly. Now I come over here, and I'm going to put a 5 here. And I will advance this now over to here. And now I'll put the 17, and I think you get the idea. 23, and then an 86. And then a 92, and this thing is sorted. So now we're actually in a position, just looking at this picture here, to actually analyze the complexity of this algorithm. You can see that in going from here, from this line here to this line here, we had to read through the numbers all at once. Okay, and going from here to here, we had to read through the numbers all at once. And in going from here to here, we had to read through the numbers once. Okay, so there was a read for this merge, there was a read for this merge, and there was a read for this merge. Well, if I'm reading all the numbers, if there were n numbers, there were n reads here, there were n reads here, and there were n reads here, or there were a total of 3n. Well, the question is where did this number 3 come from? Well, the number 3 came from the fact that I had to cut this array in half and 3 times. In other words, I cut an array of 8 in half once, and that gave me an array of 4. And I cut the arrays 4 in half once, and that gave me arrays of 2. And I cut the arrays of size 2 in half, and that got me down to an array of size 1. Basically, this number right over here, this is log base 2 of 8, which is 3. But in this case over here, this is just n. So the complexity of this whole thing over here is I get that big O of n is equal to n log n. And this is the complexity of this algorithm. Okay, so what we want to do now is we want to break this algorithm up into 2 pieces. We want to look at the merging, and then we want to look at the sorting. And let me find the code that I need. I've got it right over here. So this is right out of your book, and I'm going to basically be following the book fairly closely. There's some times here where I'm going to be referring you to, for you to look in the book. I'm not going to go over every line of code here. But so this is called public static merge. And here is the idea. You can see that I'm coming in with two arrays, okay, and I know the size of each one of these arrays, and I'm going to sort them into this array called C. So the idea here goes something like the following. I've got some array A here. So this is array A. And we don't particularly care about the size, but maybe it's 3, 18, 27, 31, 105, 222. So this is, I'll put it 0, 1, 2, 3, 4, 5. So that would mean that in this case size A is equal to 6. Now we come over here and we've got array B. I guess I should write it like that. And maybe that's a different sized array. We don't particularly care. Maybe this is 21. This is 35. This is 307. And that's 1024. And in this case we'd have 0, 1, 2, 3. And over here I would have that size B is equal to 4. So we're assuming that the array C is big enough to hold array A and B. So it's got to have 6 plus 4 is 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0, 1, 2, 3. Like that. So here's the thing that we have to do. We have these indexes, A-dex, B-dex, and C-dex, and they are all initially 0. So what that means is that over here, there's A-dex, and over here, that's B-dex. Whoops. And over here, C-dex. And let's follow this logic through. So we have over here, while A-dex is less than size A, okay, here it's 0 while it's less than 6, and B-dex is less than size B, okay, we do the following. If array A of A-dex is less than array B of B-dex, so I'm coming over here and I'm comparing these two numbers. And in this situation over here, we can see that the 3 is less than the 21. So what we're going to do is we're going to copy that into array C. So I'm going to come over here and I'm going to copy a 3 over here. Okay, and here's the confusing part. Okay, you can see that we have this, we've done this part over here. So we're going to go C-dex plus plus, the C-dex plus plus, and the A-dex plus plus. So what I've done now is I have advanced this pointer here, and I've advanced this pointer here. And now what happens is A-dex is pointing over here, and C-dex is pointing over there. And I go back up to the top, okay? It's true that A-dex is still less than size A, B-dex is still less than size B. I'm going to compare 18 and 21, and it turns that the 18 is bigger, so I'm going to execute this line right over here, and an 18 is going to get copied over to here. And now I'm going to come over here, and this is going to get 1 added to it. And this is going to get 1 added to it. So when that happens now, A-dex is now pointing here, and C-dex is now pointing here. Now in this case, it turns out that this is less than that, So I'm going to copy this down to here, and I will advance this reference here and this reference here. So I've got a 21 here. So I am now in this situation here. And in this situation here, this one is less than that one. So I'm going to copy this one over to here. And that means I will advance this reference as well as this reference. Okay, in this situation here, okay, we're going to be copying from array A. So I come over here, this is going to be a 31. In this situation here, I'm comparing 105 and 35, so the 35 will come over. Okay, so watch closely what's going to happen now. At this point, I'm going to copy the 105 from A. So I am now in this situation here. Okay, and again in this situation, I'm going to copy the 222. And now what's going to happen is I find myself like this. Here's A dex. Here's C dex. Okay, so A dex now has the value 6. And what happens up here, look at the condition controlling this while loop. While A dex is less than size A, well, this is no longer true. Okay, so I'm going to jump out of the loop and I jump down to this part of the code. Now you can see what's happening over here. I'm either copying the contents of the remaining part of A over to C, or I'm copying the remaining parts of B over to C. Is it possible to do both of these? And the answer is no, because the only way that I'm going to make it down to this part of the program is as if one of these conditions here is false. Well, it turns out in this situation here, this condition is false. A dex is no longer less than size A, which means I'm not going to execute this part. I'm going to execute this part. And what that's going to do is it's going to copy the rest of the B array over. So I'm going to copy a 307 here. This now gets incremented, as well as this. So I'm in this situation here, and I'm in this situation here, and I now copy this over to here. And now what happens is when I increment bdex, bdex is now referencing over here. It's now got the value of 4. This thing is now false, and we end the entire method here. But notice what we've done. We have merged these two arrays now into this array down here, which was exactly what we wanted to do. Okay, so that is merge. So where's this stuff called recursion? Well, it's right over here. Excuse me. Let's see how this works. So we can see that we have this method here, private void recursive MergeSort. And we can see that what's happening is we are coming in with an array, and it's called workspace here. And there is a lower bound and an upper bound. And basically the idea is if lower bound is equal to upper bound, return, there's nothing to do. Otherwise, we find a midpoint and we recursively call recursive merge sort on the lower half and the upper half. So in other words, we imagine that we've come in with an array, and it could be a subarray, it doesn't even have to be the whole array. In other words, here's 0 over here. Over here is the end of the array. There are n elements in this array. And we can imagine that we come over here. Here's lower bound. And we come over here. Here's upper bound. So at this point, we're not even paying any attention to this part of the array or to this part of the array. Okay? We're just looking at this subarray. And we're coming over here and we're adding these two together and dividing by 2, and that's getting us to some point over here. Okay, and this is mid. And then what we do is we're making a recursive call now on this array over here. And then we're also making a recursive call on this one over here. And then what we're doing, remember, after we return from all of this, this thing over here is going to be sorted, this thing over here is going to be sorted, and what we're going to do is we're going to merge them back and have this big whole thing over here like that. Well, remember what's going to happen now when I make these recursive calls. Now I'm going to be coming in over here, and what I'm going to be doing is I'm going to have a new lower bound over here, and I'm going to have a new upper bound over here, and I'm going to have a new mid right over here. And what I'm doing is I'm going to make a recursive call now on the smaller ones. And you can see that I'm going to keep getting into smaller and smaller ones until I finally get down to where these things are equal to each other. When these things are equal to each other, then I'm going to come back and merge them. And when I'm done with that one, then I'll go to the preceding one, and I'll come back and merge those. And then I'll go back and I'll merge those. So we can see how we're using the power of recursion here to get all the work done. Okay? Now, the one last thing that I want to do here is I want to take a little bit closer look at this merge. Now, I know we've already written merge, but when you look in your book where they actually give you the full code for this merge is a little bit different. And what your author does, they do a little bit of a cheat here, and I just want to make you aware of the cheat. Now, here is a part of the merge that they're using here. And what I'm doing here is I'm actually looking at the full implementation of this algorithm. And in your book, that occurs on page 288 and 289. And what I want to do, let me see if I can find it. Yeah, here's the old merge that we've already discussed. And yeah, they kind of look the same. They kind of look different, okay? And here's the thing that I want to point out to you about what your author is doing. You'll notice over here that he refers to an array, an integer array that's called workspace. And over here, you'll notice that he refers to an array that's called the array. So there are two arrays here. And one of them is called the array, and one of them is called workspace. And here is what's going on, and I think this is a little bit of a cheat, but it works. So what's going on is the original array is called the array. Okay? And we may imagine that here's the array. And this goes all the way up to here. And this is the array that we want to sort. Okay? And what's going on here is we're coming in with a couple of references. We're coming into something called low pointer, and we're coming in high pointer, and we're coming up here and there's something called upper bound. And I just noticed that's a typo there. That should be high pointer. But okay, so we're coming in here. And this is low pointer. And then we're coming in here, and way up here is something called upper bound. I think I have this right. Yes. Okay, and someplace here in the middle is high pointer. And what your author is assuming here is the following. Okay, notice that he lets mid equal high pointer minus 1. So he's assuming that from here to here, this is sorted. And he's assuming that from here to here is sorted. So what we have to do is we have to merge these two. And what he's doing is he's merging them in an array that's called workspace. And this is a big array that goes all the way up from 0 up to some big number like that. Now he's using the merge algorithm that we talked about before. So he's maintaining a reference to here, and he's maintaining a reference into here, and he's maintaining a reference into here. And again, what he's doing is he's merging these two arrays down into here. Okay, and now when he's all done merging these two into here, so over here, this whole thing is now sorted. And then what he does at the very end of this method right over here, and I ask you to go take a look in your book, go look back, he takes this thing and starting right here, he starts copying it back over here, starting at this place here. So that when we're all done, this whole thing here is now sorted. Okay? Two arrays. If you're really clever, you don't need an entire array over here to merge these two together. You could just do it with one variable. Wow. And I invite you all to try that. But with that in mind now, we basically have this entire algorithm developed. I ask you to take a look here on page 288 and 289. You actually do have to implement this algorithm for your fourth programming assignment. You are more than free to copy the code right out of the book. You may find that there are some problems that you'll encounter, but hey, that's the fun of this, and I'll leave it to you to find this all out. Okay, that's MergeSort.